Alright, so in this video we're going to be talking about partial fractions. Now, most of this video is actually just going to look like algebra. All partial fractions is an algebra thing. So a lot of places teach it in pre-calc, but in Calc 2 it's really useful because it allows us to take certain derivatives and certain integrals much easier. So what is partial fractions? Well, you know from pre-calc or from earlier maybe that if I asked you to add these two fractions together, it'd be pretty easy, I think. You'd find a common denominator. It'd just be those two multiplied. And then on the top, I'll have x minus 1. And then I gotta have minus 4 times x plus 2. And then I have gotta combine my like terms. Negative 4x and x makes negative 3x. And then minus 8, that's distributing, minus 1 is minus 9. So that's not too bad. But what does partial fractions do? Partial fractions answers the question, if I didn't give you this before, how would and I only gave you this fraction at the end, how would I decompose it and write it back like this? That's what we're trying to answer right now. So let's actually do it. Basically, all partial fractions will ask you for is they'll give you some rational function and they'll ask you to decompose it into something that looks like this. Let's do an example. X plus 1 over x minus 1, x minus 2. So I want to be able to write it so it looks like this. It's something over x minus 1 and something over x minus 2. So how do I do that? Well, the trick is to just kind of guess some answer. So I know it's going to be something over x minus 1 and something over x minus 2. So the trick is we're going to put something on top and something on top here to know there's going to be two numbers on top there that are going to make this work. And if we can solve for a and b, then we've done it. So how do I do that? I have this equation. I'm just going to get rid of the fractions on this equation. So I'm going to multiply everything by x minus 1 times x minus 2. So on the left-hand side, I got rid of all the fractions. On the right-hand side here, the x minus 1's go away. I'm left with a times x minus 2. And then here, the x minus 2's go away, and I'm left with b times x minus 1. So I'll just expand these parentheses right now. I'm after a and b. ax minus 2a plus bx minus b. The last thing I'll do, and this is you're going to understand why I'm doing this in just a second, is I'm going to group together the x terms and group together the constant terms separately. So my x terms, I have a plus b times x. And then on my constant terms, I have minus 2a minus b. So how does this help me? How do I find out what a and b are? Well, here's the trick. I have a polynomial here. I have a polynomial here. If these polynomials are the same, their coefficients, these numbers, have probably got to be the same. Like I can't have two polynomials, 2x plus 4 and minus 7x plus 10. These lines are not the same line. I've got to have these match up. In other words, the coefficient of x, which is a plus b, has got to match the coefficient of x over here. And then similarly, the coefficient of the constant term over here, 2a minus b. I should write that in red because I wrote the other one in red. 2a minus b has got to be 1. There's the constant term here. And now this is just a system that I can solve from high school algebra or college algebra. What will I do? I think I'll add these equations because I see b and negative b. So I'll add them. And I'll get 3a. B minus b is 0, and I get 2. And so a is 2/3. And then I can just take this a equals 2/3, sub it back in here. And I get 2/3 plus b equals 1. So b equals 1/3. And there's my answer. So now I have my values of a and b that make this work. 2/3 and 1/3. So that's what we were trying to do. So, in other words, what is this good for? Well, if I give you this big nasty fraction as an integral x plus 1, x minus 1, x minus 2. Well, if I've done partial fractions on it, which is what I just did, these are really, really easy integrals. I can just rewrite it as 2/3 over x minus 1 plus 1/3 over x minus 2. And there it is. How do I do these integrals? Well, these are just constants being multiplied. I can throw them out. And 1 over x minus 1 just is a log. So that's going to be 2/3 ln x minus 1 plus 1/3 ln x minus 2. And there you go. So there's your intro to partial fractions. I'm going to be doing a couple more example videos, and I'll see you in those.